Alrighty then, corn children. Children of the corn, it is a fine day for mathematics. And today we're going to be looking at a small idea, you'll be fine. A small idea from section 1.1.3 called combining functions. Now in our live class we're going to see some other techniques of combining, but for today in this little video we're going to do some pretty easy techniques. It's honestly more about notation and how to handle it. So you'll see here I have created two functions. Where did those come from? I made them up out of the blue. Yeah, that's right. I just made them up. They're functions. And here's what we want to do with these two separate functions. We want to combine our fun functions. Yeah, I know. All right. So how can we do that? Well, one simple way is we can add two functions together and get a new function. I know, right? Here's your notation. There's two different ways to write it. We can write f plus g at x. And there's another way, but I really like this way. I'm just going to go with that. F plus g at x. Well, how do we get this brand new function? Okay, it really is intuitively honest. Here's all we're going to do. We're going to write down the f function, and then we're going to add it, I know, to the g function. It's really that straightforward. I know, right? And now, of course, we can combine like terms because that's how we roll. We can even put the terms in descending order, and we have a brand new function. This function is the result of taking f and g, adding them together, and getting a new function. So if we had f plus g at 3, we could do this two different ways. We could take 3 and plug it in here, get an answer. Take 3 and plug it in here, get an answer, and then add them together. Or if we wanted f plus g at 3, now that we have the new function, we could just straight up fill 3 into this. I know, right? We could, of course, subtract functions. What? Now I'm going to be using the same f and the same g. And we can combine those with f minus g at x. This notation is telling you where the function is coming from. We're going to take the f function and subtract the g function. So sure enough, it's pretty intuitively obvious. I start with the f function and I write it down. And now I'm going to subtract the g function. Now I'm going to make a mistake. I'm going to do it on purpose. What? This is wrong. So how do we fix it? Well, right now it's minus just the first term of the g function. If we want to subtract all of the g function, as you have probably already guessed, we need to distribute the negative. So we include parentheses to say it's minus all of this, and then distribute, distribute, distribute. That is the official sound effect. So this is just a clean house. It's going to be minus x squared, negative, negative, positive 3x, negative, positive, minus 2. We could, again, if we so choose, put it in descending order, and we will get that. And again, we could fill in a variable. We could say f minus g at 4, or f minus g at 16, or whatever, and we could get the same result by straight up plugging in. Now you may have thought this was coming. You may have seen it coming, using the same f and the same g. I can now multiply. Now you'll notice there is nothing between them. We know that when we have two things next to each other, it means multiply. And sure enough, that's what we're going to do. Notationally, if we want to multiply all of f times all of g, we just put parentheses. right, right, right. Now we could leave it this way. It seems kind of strange. It's in sort of factored form. This actually factors down again, so it's kind of strange that it's factored but only half factored. So I would do one of two things. I would either factor this so it's completely factored, or I would distribute it through so it's not at all factored. It's kind of half-baked, you know? So if you wanted to see it multiplied out, you would take the 2x and distribute it. Leave yourself some room. That'd be 2x cubed minus 6x squared plus 4x. And then I would distribute, careful with the sign, -5, distribute to the back as well. Getting -5x squared, and look where I'm putting them. I know, I'm combining like terms. Plus 15x minus 10. So, just putting all that together. I think I've done that right. Here, at the very bottom, we have fg at x. And once again, you could fill numbers in. You could do fg at 3, fg at 2, and you could do that two ways. You could plug the numbers in separately, then multiply, or now that we have this function, we could just plug the number into this and get the same result. I know. Okay, well, let's see. We added functions, we subtracted functions, we multiplied. That's right. We can divide functions. I know. I bet you thought of that. The notation is a little strange. We have fg at x. And it is this straightforward. You make a fraction or a rational function out of it. We put the f function in the numerator. We put the g function in the denominator. Now, there is one tiny tricky thing to this. When we started with these two functions, there were no values that would cause division by 0. But now that we've written this as a fraction, we would want to eliminate any any values that cause division by 0. We're never allowed to divide by 0. So I would just figure that out. How? I'm glad you asked. One of the easiest ways to figure out what causes division by 0 is to factor, and I'm not going to, well, okay, I could rewrite the whole thing just because you care. And I could factor this. The factors of x squared are x and x. The factors of positive 2 are positive 2 and positive 1, or negative 2 and negative 1. These multiply to form positive 2. But which ones will combine to make -3? Winner, winner, chicken dinner. If you're not sure, you could multiply that back together and go backwards. So now that I can see this, it's pretty clear to me that the value of 2 would cause 2 minus 2 division by 0, and the value of 1 would cause 1 minus 1 division by 0. So having created f over g at x, I would put a little side note saying, oh, by the way, in case you weren't paying attention, x is not allowed to be 1, and x is not allowed to be 2, because that's how I roll. All right, so that's adding, subtracting, multiplying, and dividing functions. I'm pretty sure you saw all of this coming, and you will be good to go.